Okay, this is section what, 5.2? 5.2, and it's on page 265, the sum and difference formulas for trigonometry. Okay, I want to pose a question to you, and the question is what if I had something like this? If I had cosine of 45 degrees plus 30 degrees, okay? Would anybody consider the way to do this? Well, I know the first way to do it would be to add the two, correct?
Mm-hmm.
And then take the cosine of 75 degrees. However, can we get an exact answer for cosine of 75 degrees? No, we can't. So the question is then, how would we solve this? Because I can get an exact answer for cosine of 45 degrees, and I can for 30, because they're both special angles, aren't they? So the question is how would you solve this?
You would draw two triangles,
Okay?
and one with a 45-degree angle.
And one with the 30. So in other words, you would take the cosine of 45 degrees and add it to the cosine of 30 degrees. And what does that look like? What property does that look like?
Just
It looks like the distributive property to me, doesn't it?
yeah,
Sure.
sure.
Okay, well let's check that out. The cosine of 45 degrees. The cosine of 45 degrees, I'll help you out, it's the square root of 2 over 2.
Okay.
And the cosine of 30 degrees is the square root of 3 over 2. Okay? So if I add those two together, I get the square root of 2 plus the square root of 3 all over 2. Is that an exact answer?
Yes.
Okay. Would you tell me what that equals on your calculator? So if I'm going to look at it on my calculator,
Do you want us to take the cosine and do that way, or do you want us?
yeah, I want the cosine of that, right? Because that's what you said, right? Can you see that, or is it too dark?
I can't see.
Okay, it's too dark. Okay, so we're going to take the cosine, we're going to do cosine
45.
of, no, do the square root of 2 plus the square root of 3 over 2 first.
You wouldn't have to do cosine then, would you?
No, you wouldn't have to do, you're right. Thank you. Now make sure your appropriate parentheses are in there, okay? You gotta put parentheses over the whole top. You know what I'm saying?
Oh.
You gotta start with parentheses. This is what I got.
1.69.
I got 1.5731.
That's what I know.
Okay.
So you have to put the parentheses around.
So you go parentheses, square root
Two.
2 parentheses plus square root 3 parentheses.
Double
multiplied by
parentheses.
2.
Yeah.
Okay. So you got 1.5731. Tell me about that number. I would love for you to say, well, Mr. Ellis, that is not correct. Because cosine cannot be bigger than what?
1.
1. So let's push cosine of 75 degrees and push equals.
0.25.
That's right. The cosine of 75 degrees is 0.2588, right?
Mm-hmm.
Okay. So we have a problem, don't we?
Yeah.
Does the distributive property work?
No.
No.
It does not. Okay? So this does not work, does it? Well, so we have to do a different way because there's oftentimes we want an exact answer, correct? And since we can't use the distributive property, we had to find a new rule. And I'm not going to go through how they found the rules, but I'm going to write them for you. Okay, do you remember that little card that you have?
Yeah.
Okay, we're going to write these rules on there. Okay? So, now, I will actually let you use these rules on the test. I won't have you memorize them. Well, no, I take that back. I'm going to have you start by memorizing, and then we'll work our way. The first one is, if I take cosine of A plus B, okay? then this equals the cosine of A, cosine of B, minus the sine of A, sine of B. Now, I want to show you something. We have both cosines, right? Right?
Yeah.
And then both sines, and it's AB. So it goes in the same order as this, AB, right? But this sign and this sign are the opposite, aren't they? This is addition, so this is subtraction. So what would happen if I switched them and said A minus B?
It'd be plus.
All right, this would be cosine of A, cosine B, plus the sine of A, sine of B. So it's the exact same formula, only change the sign. These are called sum and difference formulas. Okay, what they allow us to do is to find exact answers for other angles besides 30, 60, 90. Okay? Now, if there's two cosines, what do you suppose there is also a sine?
Yeah.
You bet. The sine, we'll start with sine A plus B. Is the sine of A cosine B. Okay, notice that it switches, right?
Why is it cosine?
Because that's the formula. I could derive it for you, but it would take about 20 minutes, and you don't really care, do you?
No.
Okay.
It's
all right.
just weird.
Yes. So then the sine of A plus B would be the sine of A, correct? Cosine of B, so it starts out the same way, only it's subtract. Whoops, this is minus. Sorry. So sine actually works, doesn't it? It has the same sign, doesn't it? Have you noticed that? Then in cosine, it was the opposite signs. In sine, it's the same, right?
Yeah.
Okay. And there's also two tangent ones, which you really wanted to know, right?
That's great news.
Yep. And this is really where the tangent of A plus the tangent of B, and these are fractions, so we want to avoid using these if we can, right? Okay, so I'll read it to you. It's tangent of A plus tangent of B all over 1 minus tangent A times tangent B. And then if we subtract them, the only thing that changes is these two signs.
Plus and
This
minus.
becomes minus, this becomes plus. So it's tangent of
And
A.
the tangent becomes minus, or the first part becomes minus. Right?
What's that?
The first part becomes minus.
Yes. And the second one becomes plus. And those are your those are your 6 sum and difference formulas. Okay, so what can we do with them? Well, the first thing we can do is find the exact value for each. Okay? All right, so I can do number 1. Let's go that cosine 75 degrees. Now we now know what the decimal approximation is, but we want to know the exact, right? So this is 75, so I have to come up with 2 angles that add up to 75 or subtract to 75, correct? That we can find the exact value of. And we already found that, didn't we? Right back up here, right? This equals the
45.
cosine of 45 degrees plus 30. So this is a plus, right? So I find the appropriate formula, which is cosine plus, and I take, and I'll look at this, and Joey's right, we haven't got to it yet, but what I do is I do the cosine of 45 degrees times the cosine of 30 degrees. I'm just following the formula, right? And I subtract, because it's addition, the sine of 45 degrees and the cosine of 30 degrees. Okay? Oops. That should be sine.
What would you,
Hold it. This is sine. What would I what?
what would happen if, like, say you put 30 is the A and 45 is the B?
It doesn't matter.
Doesn't matter?
It doesn't matter. I can flip these two in this, okay? That's a good question. Yes?
When do you know when to like use the,
Which formula?
yeah,
When do I know?
yeah,
I had to come up with how to get 75 from 45 and 30.
okay.
I use 45, 30, and 60,
That's
and
the
a
only
combination.
Use.
Yes.
That's the only one.
So I can find the sine of 15 degrees because I can take 45 minus 30.
Okay.
Okay? Then I could take 45 plus 60. I mean, I can do any combination of those three and find the exact answer.
Okay.
Okay? So now, I have to draw A and B. Okay, so what I do is I draw 45, 45. So this is 45. Wow, that's too small, isn't it? Okay, I'll just take the whole thing here. This is a 45, 45, 90, okay? So this is 1, and this is 1, and this is the square root of 2. Is that correct?
Yeah.
Okay. So the cosine of 45 degrees is equal to adjacent over hypotenuse, which is the square root of 2 over 2, right?
Yeah.
And
Adjacent over.
Might as well just do sine of 45 degrees while we're here, right?
Yeah.
Sine of
sure.
45 degrees is the same thing, correct?
Yeah.
All right. Now we're going to do a different triangle. And this is a 30, 60, 90. And I just labeled a 30. Across from the 30 is 1. Across from the hypotenuse is, or the across from the right angle is hypotenuse, it's 2. And this is the square root of 3, correct?
Mhm.
So we want the cosine of 30 degrees, right?
Yes.
The cosine of 30 degrees is adjacent. It's square root of 3 over 2, correct? And then the sine of 30 degrees is 1 or 1/2, right?
Yes.
All right, so up here now I can plug these values in. If I just go left to right, cosine of 45 degrees is the square root of 2 over 2 times the cosine of 30, which is the square root of 3 over 2. Is that correct?
Mhm.
All right. Minus the sine of 45, which is 1/2, times
Square root of 2 over 2.
the sine of 30, which is the square root of 2 over 2. So I'm sorry.
No,
Those are
that's
reversed.
Other way around. Other way around.
It should be
Square root of 2 over 2
Thank
times.
you.
It doesn't matter, but.
Yes, but we want to make sure we get it right,
One.
especially for Maggie. So then times 1/2, is that correct?
Yeah.
Okay, so I have the square root of 2 times the square root of 3 is the square root of 6 over, what, 4?
Yeah.
Over 4.
Minus the square root of 2 over 4. And since they have the same denominator, we can put them together. Square root of 6 minus the square root of 2 all over 4. That's an exact answer. Now, would you please put that in your calculator so we can check to see whether it is close to that decimal? Okay, so make sure you put parentheses around the square root of 6 and the square root of 2 when we subtract them. You should get
Yeah.
0.2588.
Yep.
Yeah.
All right.
Exactly what you
Okay. Yeah, you understand the sum and difference plan.
do. Yeah.
Now that was cosine, right?
Yeah.
I can use sine also, all right? But they're going to ask you to do some figuring. So I'm just going to kind of follow the examples because they do the same in the book, and then I'll go to more of it. Okay? Let's say that they had, you got the formulas. I took them off the page, right?
Yeah, we.
All right. Let's say that we have this number 2. Show that cosine of 90 degrees minus A is equal to the sine of A. Okay, so show means the same as prove, okay? Do you see this? This is a subtraction, right? So we're gonna use the subtraction rule, correct? Which says that we have the cosine of 90 degrees times the cosine of A plus the sine of 90 degrees sine of A, correct? And we want that to equal sine of A. Does everybody follow me? So I took this side, which is more complicated, and I broke it apart using the rule. Okay, do you understand that, Josie?
Yeah.
Okay, now, here's where it gets weird. What is the cosine of 90 degrees? And 90 degrees cosine is? It's a quadrant angle. No, it's not. It's 0.
0.
It's 0 times cosine of A plus, now what's the sine of 90?
9 is 0.
It can't be 0.
Oh.
It's a quadrant angle, it's up. So it would be what?
1.
1 times sine of A, right?
Mhm.
What is 0 times cosine of A?
0.
And 1 times sine of A?
1.
Sine of
Sine of
A.
A.
And that equals sine of A. You see that?
Yeah.
So I've used that rule to do that, correct?
Yeah.
All right. Any questions about that?
So you just broke it up, right?
Yes, I used the rule though. You can't distribute it. You have to use the rule. The distributive property doesn't work, so we have to use those sum and difference rules.
Which rule? You
I used,
cosine minus?
yes, I used the second rule, this one right here.
Okay.
All right, you got it?
Yeah.
Okay. All right, so now I'm going to turn to page 270. Page 270, this is example 7. We're going to call it example 3. It says if the sine of alpha equals 3/5, okay? And alpha is in quadrant 1. Okay, this is what I know, correct? I also know that the cosine of B is a negative 5/13. And B is in quadrant 3. Okay? Then I want to find these three things. I want to find the sine of A plus B. Okay? I want to find the cosine of A plus B. And I want to find the tangent of A plus B. Are you all with me?
Yeah.
Okay.
You said you're gonna be on all one.
Yeah, that's why I put a lot of space there. All right, so we'll start and we'll draw, and you want to draw a quadrant in quadrant A, and I'm going to need a bigger picture because I just can't. Okay, so this is A and this is B. Okay, A is in quadrant 1, so it's like this, correct?
Yeah.
Okay, it's a right triangle in quadrant 1, and sine is 3/5. So here's A, right? Here's A. Okay, it's 3/5, and it's sine. So here, this is 3.
So it's
and this-
adjacent,
No, it's
no,
opposite.
opposite over hypotenuse.
Right, but then we got to find this guy. How do we do that? Pythagorean theorem.
Pythagorean theorem.
That's correct.
9.
So what?
20.
5 squared.
25 minus 9 is 16, so this is 4.
4.
All right, we good?
Yeah.
Okay, so now we come down here to B. B is in quadrant 3, so we put a right triangle to quadrant B, or to quadrant 3.
No, it's 5.
This is B,
Mm.
and it's cosine, so it's adjacent, so this is negative 5, and this is the hypotenuse, 13. So we use the Pythagorean theorem.
Yeah.
Be 169 minus 25, which is what, 144?
Minus
144, so
12. Is it positive or negative?
12. Negative.
negative.
Okay, the reason they tell you what quadrant it's in is so you get the right sign.
Yeah.
All right. We good?
Yeah.
Now we got our A and our B drawn, correct?
Yep.
All right, so we go over here, and the formula for sine of A plus B is the sine of A cosine B plus, sine's the same sign, isn't it? Yep. Cosine of A,
Sine A, cosine B.
sine B. Is that right?
It's sine A, cosine
B plus cosine A, sine B. That's what I got.
Yeah.
Okay, so let's plug in. What is the sine of A? We go to A. See where my finger's at?
Yeah.
I go to A and I do sine. What's the sine? 3/5 times cosine of B. So I'm going to jump down to B and I'm going to do cosine, which is
Negative 5/13
negative 5/13
plus.
plus, I go back to A and I do
4/5
cosine,
4/5.
times
times negative 12 over 13.
negative 12 over 13. So I get over here negative 15 over, I believe that's 65, isn't it? Plus a negative 48 over 65. What's a negative 15 and a negative 48?
Adding
Yep.
negative 15 plus negative 63.
Negative 63 over 65. You got it? We good?
Yeah.
Hold on, I'm sure I should.
Okay. We okay?
Yeah.
Okay, let's do cosine A plus B. All right, so this is A plus B. So we're going to use the first formula I gave you, right? Which is cosine A,
Yep, so that is.
cosine A, cosine B,
Is, yeah, 4/5.
minus sine of A. You can go ahead and plug in. I'm going to write it for Maggie's sake. So I'm getting cosine A, which is 4/5
4/5, yep.
times cosine B, which
Negative
is
5/13
negative 5/13.
plus 3.
Minus, it's minus
Oh, minus
sine of A is 3/5.
3/5 times.
Sine of B, which is negative 12/13.
Yep.
So I get negative 20 over 65 minus a negative 36 over 65. And so I got plus a positive. So 36 minus 20 is 16 over 65.
So for all these, will the common denominator be 65?
Yes. If, well, it depends on what you're finding. But in this case, since we're finding, sine and cosine, yes. All right. Now,
What's the answer?
tangent,
16 over 65.
tangent we could use the tangent formula, but it's much easier just to use the sine of, because it's both A over B, right? We found both A over B, right?
Oh, yeah.
Now, if this said tangent of A minus B, you're in trouble.
Yeah, then you gotta do it all.
Then you got to do it all over again or use the tangent formula. Well, I would use the tangent formula, it'd be simpler. But we can just take the sine of A plus B over the cosine of A plus B since we got both of them done, right? So the sine is a negative 63 over 65,
What? Oh, yeah.
and that's over the cosine, which is 16 over 65. So if we do it elementary style, we have 63 over 65 times 65 over 16. And the 65's cancel. And tangent is a negative 63 over 16. I can't read my writing. And then we didn't have to do all that, did we? Okay? Questions?
What? How does it? Oh, that's just the answer.
That's just the answer. So here's an answer, here's an answer, and here's an answer. Questions?
You don't have to simplify or anything?
Huh. Well, 63 and 16, you would have to if there was something that went in between, them, but we don't have to do that, right? All right. Questions?
No.
All right. So let's take a look at example 8, which we're going to call example 4. And it says, if sine equals, sine of A is 3/5. And I'm only gonna do one here. And A is in quadrant 1, right? And B is, cosine of B is a negative 5/13. So does this look familiar?
Yeah.
It's, and B is in quadrant 3. So we're basically using the same, right? So I'm not gonna draw them, I'll refer back to them, right? Okay, let's say that I wanted to find the tangent of A plus B and I wanted to use the tangent formula. Okay, so I would do tangent A plus tangent B all over 1 minus,
We should get the same answer as last time.
yeah, what I'm showing you is how to do
How
this.
to do it in tangent,
Yeah.
right?
Right,
So,
okay,
tangent A
you ready?
plus tangent.
Okay, so what I would do is, I would still have to draw the triangles, and I'm not gonna redraw the triangles, you have them on your paper, but I'm gonna bring them over. I want the tangent of A, so the tangent of A, let's take a look at A. The tangent is what? It is 3/4, right? So I'm just gonna write that down, the tangent of A is 3/4, okay? And let's look at B, the tangent of B, it is negative
12.
over negative 5, so it'd be positive 12/5. Alright, did we get that? Okay, so what we would do is, we would plug in this formula, we would take the tangent of A, which is 3/4, and we would add to it the tangent of B, which is 12/5, correct? All over 1 minus those two numbers times each other, okay? So on the top, if we got a common denominator, I believe it's 20, right?
Yeah.
Yes.
So the first one would be what, 15, and the second one would be 48? Is that correct?
Yes.
Yeah.
And on the bottom, we get 1 minus 36 over 20, correct? Are we good?
Yeah.
Okay, so if I add the top, I get 63 over 20, correct?
Yes.
Over, and if I get a common denominator, it is 20 over 20 minus 36 over 20, correct?
So it would be 16 over 20.
So it'd be a negative 16, wouldn't it? So 63 over 20 over a negative 16 over 20, correct? Elementary division, 63 over 20 times the reciprocal, 20 over a negative 16, the 20s cancel. Voila, peanut butter and jelly sandwich. I get the same thing that I got from the previous page,
Why
right
is it a
there.
negative 16? I don't understand that.
It would be 20
20
minus 36, which is negative.
Okay.
All right, any questions?
I don't think so.
All right, so your assignment is page 272,
Here, I'll go right out.
numbers 2 through 26 even. And then 36 through 38 all. And then 44 through 50 even. It is due Monday. And we'll start a new section on Monday. I'll record it too.